We'll work with a logarithmic expression in this exercise. If the log base a of x equals 2, the log base a of y equals 3, and log base a of z equals 4, we're going to find log base a of the cube root of x squared z over the cube root of y squared times z to the negative 1 power. Now what I want to do with this expression is to break it down so that it's given all in terms of log base a of x, log base a of y, and log base a of z, so that I can substitute for those values. And we'll use what we know about radicals and what we know about logarithms to do this. We'll rewrite the expression, the log base a of the cube root of x squared z over the cube root of y squared times z to the negative 1 power. And first I'm going to write this quotient of cube roots as the cube root of a quotient. So I'll write the log base a of the cube root of x squared z over y squared times z to the negative 1 power. And now let's just simplify underneath this radical sign. First of all, I've got a z in the numerator and 1 in the denominator. So I'm going to write this as the log base a of the cube root of x squared, and z divided by z to the negative 1 is z to the 1 minus negative 1 power, or z squared. And that's going to be over y squared. Now I can rewrite this radical with a rational exponent as the log base a of x squared z squared over y squared to the 1/3 power. Now we're going to need some more room here. We had the log base a of x squared z squared over y squared to the 1/3 power. This is what we had gotten equivalent to the original expression. I'm going to use a property of logarithms that says that I can rewrite this as 1/3 times the log base a of x squared z squared over y squared. And now I'm going to use the property of logarithms involving the logarithm of a quotient. I can write this as 1/3 times the log base a of the numerator, x squared z squared, minus the log base a of the denominator, y squared. And next I'm going to look at this logarithm of a product and write it as a sum of logarithms using another property of logarithms. So I'm going to write this as 1/3 times the log base a of x squared plus the log base a of z squared, and then I have minus the log base a of y squared. And now in each of these, the log base a of a number to a power is that power times the log of that number, so the log base a of that number. So I'm going to rewrite inside the parentheses, and I'll have 2 times the log base a of x plus 2 times the log base a of z minus 2 times the log base a of y. And now I do have this broken down the way I wanted in terms of logarithms of log base a of x, z, and y. And we were told, remember, that the log base a of x is 2, the log base a of y is 3, and the log base a of z is 4. So I'm going to do some substitutions here. I'll have 1/3 times 2 times the log base a of x, which is 2, plus 2 times the log base a of z, which is 4, minus 2 times the log base a of y, which is 3. So I have 1/3 times 4 plus 8 minus 6, which is 1/3 times 6. That makes the final result 2.